So, good day, everyone. I am Priscilla Sarto, and together with me in this um project is Aurora Benavides, and we will be presenting our data science project entitled Harmonizing Success, a Predictive Modeling of Taylor Swift's Song Popularity in the Spotify platform using machine learning. So, you might wonder why we chose Taylor Swift. Well, basically, she is one of the most popular, if not one of the most, is the most popular artist nowadays worldwide. Um, a data science project on predicting the popularity of Taylor Swift songs has the potential to provide actionable insights for the music industry, especially on a artist of her caliber. Impacts marketing strategies, content creation, and overall decision-making process. It aligns with increasing trends of leveraging data-driven approaches to navigate the complexities of the entertainment business. So the Taylor Swift Spotify data that we use is updated until 2021. The Kaggle link of the dataset will be on the reference section, so you can directly download the CSV from that site. But no worries, we will also be attaching it on our project submission. So now let us import the necessary libraries and upload the CSV files. Of course, pandas and numpy, matplotlib, pyplot for the charts, and seaborn also for the charts that we're gonna generate. So now let's import the CSV file. Now the CSV file is uploaded correctly. Let's check the info. So right off the bat, there's no null um counts here. And then let's check the first five. Here we can see around around 14 to 15 features. So yes, the CSV is now successfully uploaded.
The next section of the code focuses on cleansing the data. It performs various operations to clean and pre-process the data before further analysis. Checking if all the values under the column instrumental are zero. Observing that not all values are zero, we choose not to delete this column. As all entries in the artist column belong to Taylor Swift, we can safely remove the artist column. Additionally, we can eliminate the index value column. Now let's check for null values. No null values exist in the dataset. It compresses a total of 14 features and one dependent variable, which is popularity. Following the data cleansing process, here are the results. Popularity analysis follows as we create a histogram to visualize the distribution. The x-axis denotes the popularity score of Taylor Swift songs on Spotify, ranging from 0 to 80. This score reflects the song's popularity on the platform, with higher values indicating greater popularity. Meanwhile, the y-axis represents the number of songs within each popularity range. The height of the bars at a specific popularity score signifies the quantity of songs attaining the level of popularity. Plotting the popularity distribution reveals a potential for normally if we exclude the lowest data on the left So let's proceed to drop it. Now observe the histogram after eliminating the two data points with the lowest popularity. Next, we'll plot QQN probability plots to confirm the popularity column adheres to a normal distribution. Recognizing this normality is crucial for simplifying analysis and ensuring accurate modeling in subsequent stages. The QQNPP plots suggest that it follows a normal distribution. It is considered a normal distribution because it aligns with the straight line. Plotting the popularity distribution has significantly improved, revealing a nearly normal distribution with a slight left skew. Okay, to start, okay.
So now moving on to the exploratory data analysis or EDA phase. We have a general problem statement of the music industry faces challenges in understanding and predicting the factors influencing the popularity of songs. In particular, there is a need for robust predictive models that can analyze diverse features and provide insights into what makes certain songs more popular than others. So our study wants to contribute to that dilemma as well as kind of have more studies out there as baseline models. So the data science questions that we have formulated three. First is within the feature importance. So which features such as musical characteristics are most apparent in the more popular Taylor Swift songs? We have the objective of understanding the relative importance of different features in contributing to song popularity. And then that's with temporal trends. We want to ask how have the factors influencing song popularity evolved over time in Taylor Swift's discography. This has the objective of exploring how changing musical trends and industry dynamics have influenced the popularity of Taylor Swift songs. Lastly, a genre-specific analysis question. What genre-specific features contribute most to success? Which we want to investigate whether certain genres or genre-specific features play a significant role in the popularity of Taylor Swift songs, providing insights into genre preferences among her audience.
Okay. To start, we'll sort the data and calculate calculate the mean popularity value for each album. From the results, it is evident that Lover, Reputation, and Fearless, Taylor's version, stand out as the top three popular albums by Taylor Swift. Moving on, we're now finding the top 10 popular songs. So having conducted the review, we can now identify the top 10 songs. Finding the relationship between various columns of the top songs, we find that 5 songs are from the Lover album, 3 songs are from the Reputation album, and 2 songs from the 1989 Deluxe album. So it is noticeable that the majority of popular songs exhibit high danceability and belong predominantly to the pop genre. Indeed, there is a clear and strong correlation between energy and loudness. Additionally, a positive correlation between valence and danceability suggests the happy and positive songs tend to be more danceable. Now let's find the most energetic songs. After careful review, it appears that the most energetic songs are predominantly from pop albums such as Lover, 1989, and Red, as well as pop rock in the case of Speak Now. Notably, Fearless and Taylor Swift fall under the country pop genre. Moving forward, we'll examine the danceability of each album. So the top three based on danceability are Lover with the danceability of 0.65, Reputation with the danceability of 0.65, and 1989 Deluxe with the danceability of 0.62. So, observing the data, it's apparently that Lover and Reputation stand out as Taylor's most popular albums, and interestingly, these two albums also boast the highest danceability among her discography.
So now with that data, let's move on to the modeling. So now let us try to run a model to predict the popularity of songs. Let us first review our data again. Now we can drop the album and the release date since these two features are not necessarily needed. And then let's also drop the tempo, acousticness, energy, balance, instrumentalness. Um, Popularity is our dependent variable, and we're going to shift that to the leftmost side. So insert popularity. Path. Let's check our current data set that we're gonna be working on. So we have the danceability, liveliness, loudness, pitchiness features in order to predict the popularity by starting the independent variable and then the dependent variable. So for our baseline model or our model one, we chose linear regressions. It's very simple. It's a good baseline or a benchmark. So let's import the important modules for linear regression. So our testing size is 30%. Let's have score. We have the score of 0.24 and the R squared score. Let's run that again. Okay, so now we have a benchmark of 0.24. So here we're gonna know if the other two models that we chose is better than the benchmark. So the model 2 is a random forest regressor. I just imported the important modules for that and then chart the R squared score. So we had a 0.40. So obviously it's better than the baseline model with it, which is 0.24. The accuracy results is also better. It's also around this one. We can see that that most of our predicted values are closer to the actual value. We can see that. So we also research another model, which is gradient boosting regressor. So it has the result of 0.36 or 37. It is obviously better than the baseline of 0.24, but the random forest still gave us a better result of 0.40. So let's check the resulting table. So in summary, based on this result, the random forest regressor seemed to be the most effective model as it exhibits the highest accuracy and R squared score in the test set as well high accuracy scores during the training.